This video is going to be part 2 of lesson 3, and lesson 3 was analyzing rational functions. In part 1, we looked at vertical asymptotes. So we looked at non-permissible values, which were introduced in Math 20-1, and then we talked about non-permissible values are going to be either vertical asymptotes or they're going to be holes, otherwise known as point of discontinuities. What we're going to be doing in this lesson is looking at horizontal asymptotes. So that will be the focus of this part 2 in the video. Okay, looking at horizontal asymptotes, remember that we're dealing with rational functions. So we're dealing with fractions, and a rational function is written in the terms of f of x is equal to n of x and d of x. N of x and d of x, numerator is a polynomial and denominator is a polynomial. So we're just going to denote the numerator by n of x and the denominator by d of x. Okay? And what we're going to look at is first off, where they have no common factors. So what happens is there's going to be 3 scenarios, and these 3 scenarios you just have to be very familiar with. So scenario 1, scenario 2, and scenario 3. In scenario 1, it says the degree of n of x is less than the degree of d of x. So I'm just going to highlight that. The degree of n of x is less than the degree of d of x. So we're going to be looking for horizontal asymptotes. We're going to be looking at the degrees of each of these polynomials. And for situation number 1, they're saying if you have the degree of your numerator is less than the degree of the denominator, we are going to have a horizontal asymptote, and the horizontal asymptote is going to be at the line y is equal to 0. So the 2 things you have to memorize is if the degree of n of x is less than the degree of d of x, we're going to have a horizontal asymptote at the line y is equal to 0. So I'll show you an example of this. What would an example be? So let's just say our function f of x is equal to 3 over x. So a few things. We know from the previous lesson that x could not be equal to 0. That's a non-permissible value, right? So we know that this function is going to have a vertical asymptote at x is equal to 0. So that's the first thing. That's what we did in the last lesson. But now what we're going to do in this lesson is we're going to look at the degrees of the function. So f of x is equal to 3 over x. This is a degree 0, and this is a degree 1, right? There's an invisible 1 there. So if you have a rational function where the degree of the numerator is less than the degree of the denominator, so the degree of n of x is less than the degree of d of x, what we are going to have is we are going to have a horizontal asymptote at y is equal to 0. So I have 2 asymptotes happening. I have a vertical asymptote is the first asymptote in the graph at x is equal to 0. That's the non-permissible value. And then I have a horizontal asymptote happening in my graph at x is equal to 0, or sorry, at y is equal to 0. Okay, so there's 2 asymptotes that are now happening. The second scenario, okay, so the second scenario, scenario 2, if the degree of n of x is equal to the degree of d of x, so they're equal. So we'll write that down. Degree of n of x is equal to the degree of d of x. We are going to have a horizontal asymptote at the line y is equal to a over b. And what it says is a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So let's see this, an example of this, of number 2. Okay, if I gave you f of x is equal to 2x all over x plus 1. So again, remember from the first lesson, so part 1, we need to find the non-permissible value, and that's going to give us our vertical asymptote. So I would say, okay, this x plus 1 cannot be equal to 0, so x cannot be equal to -1. Therefore, there's a vertical asymptote at x is equal to -1. There's going to be a VA at x is equal to -1. But now I need to find the horizontal asymptote. So the horizontal asymptote, I need to look at the degree. This is a degree 1, and this guy, this x, is to the power of 1, so that polynomial is a degree 1. So what we have is we have the degree of n of x is equal to the degree of d of x. Therefore, we have a horizontal asymptote at the line y is equal to a over b. Now we have to figure out what a and b are. A and b are the leading coefficients of the numerator and the denominator. So the leading coefficient of the numerator is 2. That would be my a value. And the leading coefficient of my denominator is going to be 1. That would be my b value. So this graph, it's going to have a horizontal asymptote at y is equal to 2. So what I want to show you is I want to actually show you this graph, how there's a vertical asymptote at x is equal to -1 and a horizontal asymptote at y is equal to 2. So remember that when we punch in rational functions, if it has more than one term, you always want that to be in a bracket. So I'm going to put that denominator in a bracket. So take out your calculators, and when y is equal to, so let's punch in the numerator, which was 2 of x, divided by, let's punch in the denominator in its own bracket, which is going to be x plus 1. Okay, when I examine the graph of this function, what I hope you could see here is this is going to be my vertical asymptote, right? And the vertical asymptote was at x is equal to -1. So there's an invisible vertical line here that my graph will approach but never touch or cross. And then there's actually at 2, there's going to be a horizontal asymptote. I could put in for you here, I could put in y is equal to 2. And this is the line of the horizontal asymptote. It looks like it's touching it, but it's not actually touching it. So it's really getting close to it, but it's not touching or crossing it. Okay? The third example of horizontal asymptotes, and then the rest of this video will be just applying these 3 examples. The degree of n of x is greater than the degree of d of x. So let's look at an example for this. So degree of the numerator of n of x, just let me erase that bracket, degree of n of x is greater than the degree of d of x. What we're going to have, if that's the situation, we're going to have no horizontal asymptote, okay? So if that's the case, we have no horizontal asymptote. So let's look at a situation that would model this. So number 3, if I gave you f of x is equal to x squared all over x minus 2. Okay, from uh, lesson 1 or part 1, let's first find the vertical asymptote. So we know that x minus 2 cannot be equal to 0, finding my non-permissible value. X cannot be equal to 2, therefore there's a vertical asymptote at x is equal to 2. So this graph has a vertical asymptote at x is equal to 2. And then from there, we need to find the degree of the graph. So we know that this is a degree 2, and we know that this is a degree 1. The denominator is a degree 1. So this is a scenario where the degree of n of x, the numerator, is greater than the degree of the denominator, right? N of x is greater than the degree of the denominator. And in that case, we have no horizontal asymptote. So no horizontal asymptote. Okay, let's look at what examples would be. And again, if you understand these 3 scenarios, they're going to be one of these 3. So for each rational function, determine whether the its graph has a horizontal asymptote. If it does, write its equation. And we're also, of course, going to determine vertical asymptotes. Okay, so class example number 1, or A, what we are looking at is, again, I always start with non-permissible values. So x plus 2 cannot be equal to 0. X cannot be equal to -2. Therefore, a vertical asymptote at x is equal to -2. Okay, so I'm going to start there. From there, I'm going to look at the degrees. So now I'm going to figure out the horizontal asymptote. And I'm going to say, okay, this has a degree 1, and this is a degree 1. So what we have is we have the degree of n of x is equal to the degree of the denominator, d of x. So then you have to, like I said, remember from that previous slide, well, what happens if the degree of n of x is equal to the degree of d of x? Because we have degree 1 is equal to the degree 1. And if you went back to that slide, when they're equal, we have a horizontal asymptote at the line y is equal to a over b. So what I do is I say, okay, therefore, we have a horizontal asymptote at the line y is equal to a over b. A is a leading coefficient of the numerator, and b is a leading coefficient of the denominator. So the leading coefficient of the numerator is 4. The leading coefficient of the denominator is 1. So we have a horizontal asymptote at 4 over 1, horizontal asymptote at, because it wants the equation, y is equal to 4. So again, let's graph this, and let's look at the two asymptotes, a vertical asymptote at -2 and a horizontal asymptote at y is equal to 4. And let's see if we're correct. So in y1, we're going to punch in 4x. So we're going to punch in our numerator first, divided by our denominator, and our denominator is x plus 2. And when I graph this, okay, so what I have is at x is equal to -2, there's an invisible vertical asymptote here. Okay, so that's for my non-permissible value in the denominator. And then at y is equal to 4, and I'm going to put this line in, at y is equal to 4, there's a horizontal asymptote that my graph approaches, but it does not touch and it does not cross. Let's look at b. Remember, we always want to be in factored form. So a was in factored form. We need to factor this guy. So we're going to look at the product sum answer. What gives me a product of 4 and a sum of -5? Okay, so that answer is -1, -4. Let's rewrite our equation. Y is equal to x minus 4 all over x minus 1, x minus 4. Okay, so we have a lot of things happening here. From our last lesson, or part 1, you were taught that if you have a common factor, that is going to be a whole, right? So a common factor is going to be a whole. So let's take care of the whole first. I know that there's going to be a whole at x minus 4 cannot be equal to 0, x cannot be equal to 4. There is going to be a whole in here at x is equal to 4. And I'll find the point of my whole in a bit. So a whole or a point of discontinuity at x is equal to 4. Down here, this accounts for vertical asymptote. So x minus 1 cannot be equal to 0. X cannot be equal to 1. Therefore, we have a vertical asymptote at x is equal to 1. So I've got a whole at 4, point of discontinuity. I have a vertical asymptote at 1. And now I need to figure out my horizontal asymptote. So my horizontal asymptote, I could look at it in one of two ways. I could look at the original function. So I could say, okay, this is a degree 1, and this is a degree 2. So figuring out the horizontal asymptote, I'd say numerator, so n of x, is less than d of x, right? And what happens if we have n of x is less than d of x? So if you go to your scenarios, and if n of x is less than d of x, we are going to have a horizontal asymptote at the line y is equal to 0. So I'm going to put that in. Okay, so I've got a vertical asymptote, I've got a horizontal asymptote, and I've got a point of discontinuity. The last thing I need to do is find the point of what point does my hole exist at. So remember what you do for that is you have to be fully factored and simplified. So if I was to simplify this, I'm going to cancel out that. And what I'm left with is y is equal to 1 over x minus 1. And now I'm going to put in that f of x is 4. So I'm going to calculate f of 4, and I get 1 over 4 minus 1. F of 4 is equal to 1 over 3. So I'm going to have a hole or point of discontinuity at the coordinates of 4 and 1/3. I'm going to have a vertical asymptote at x is equal to 1. And I'm going to have a horizontal asymptote at the line y is equal to 0. We will do one more class example, and then that will be it for part 2, and I will be doing a third part. So again, it says for the graph of the function, determine any non-permissible values of x and indicate whether each is a vertical asymptote or a hole. So remember that whenever we're given a rational, we must factor. So I'm looking here for what gives me a product of -12 and a sum of -1. So let's see, product of -12, sum of -1 is 4 and 3. So 3 and -4. So what I have for this example, writing this in factored form, I'm going to have y is equal to x plus 3 all over x plus 3, x minus 4. Okay, get in the habit of highlighting your common factors, and remember that common factors are wholes. So this guy and this guy, that's a common factor. There's going to be a hole there at that common factor. So let's figure out the hole, and then we'll figure out the vertical asymptote. Okay, so x plus 3 cannot be equal to 0. X cannot be equal to -3. Therefore, there's a hole at x is equal to -3. So the point of my hole, which I'll find in a minute, it's going to be -3, comma, I have to figure out that y value. Okay, so that's going to be the point of the hole. Then let's figure out the vertical asymptote. So the vertical asymptote comes from this guy. Remember, vertical asymptote comes from where there's no common factors. So x minus 4 cannot be equal to 0. X cannot be equal to 4. Therefore, there's a vertical asymptote at x is equal to 4. Okay, let's do the horizontal asymptote. So horizontal asymptote, we need to find the degree of the polynomial. So degree of the polynomial, this is a degree 1. It's a first degree polynomial. And this is going to be a degree 2. Okay, we have the degree of the numerator is less than degree of the denominator. So you have to have that memorized. What is it if you have numerator is less than the denominator? And what that's going to be is a horizontal asymptote at y is equal to 0. Okay, let's find the equation of the hole now. So let's find, sorry, the point of the hole. So remember that after you're fully factored, you take out your vertical asymptote, you take out your horizontal asymptote, you figure out your hole, and then we're going to simplify. So this guy is going to cancel with this guy, and I'm going to have y is equal to 1 over x minus 4. I need to figure out the equation of the y value when my whole is at x is equal to negative 3. So f of negative 3 is equal to 1 over negative 3 minus 4. F of negative 3 is equal to, and we are going to have 1 over negative 3. Sorry, I'm just looking at this. So negative 3, oh, sorry, this should be a 4. I was like, where's my mistake? Okay, so negative 3 minus negative 4 is 1 over negative 7. So my whole is that x is negative 3 and y is negative 1 over 7. So that's my whole, or remember, wholes are commonly called points of discontinuity. So again, vertical asymptote, horizontal asymptote, whole this graph has. And now we're going to talk about domain and range. So for the domain and range, what we're going to do is this graph. So if you wanted me to graph it, so I'll show you what the graph looks like first of all. So let's put x plus 3. Remember that I'm going to put this in its own bracket, and I'm going to put this in its own bracket. So numerator is going to go in a bracket, and denominator is going to go in a bracket. So let's see what our graph, this rational function looks like. So open bracket, x plus 3, close that bracket, divided by x squared minus x minus 12. Okay, so let's examine this. What we have happening here is at the line y is equal to 0, so this line here, we have a horizontal asymptote. Then I have a vertical asymptote here, and that's at x is equal to 4. Then there's a hole in this graph. So let's check if the hole does exist. So second function, calculate a value. When x is equal to, we said the hole was at negative 3. Yep. So at negative 3, we have an empty set. So that's going to be our hole. Now if we're talking about our domain, so how do we do our domain for this? What we say is this graph goes to negative infinity, and over here it goes to positive infinity. So normally I'd want to say x belongs to the set of real numbers. However, I have to talk about the whole, and I have to talk about this. So x could be any number except for negative 3, right? We said x cannot be negative 3, and it also cannot be 4. So how I would do my domain is I would say x is such that x cannot be equal to negative 3 or 4. But other than that, I say x belongs to the set of real numbers. That's how I would do the domain. Okay, let's find the x and the y-intercepts. So y-intercept, you let x equal to 0. Okay, so y-intercept, you let x is equal to 0. So in my equation, and I could actually take the equation of my simplified rational. So in the equation, y is equal to 1 over x minus 4. You're going to let y equal, or x equal to 0. Y is equal to 1 over 0 minus 4. Y is equal to 1 over negative 4. So the y-intercept for this is going to be at x is 0 and negative 1/4. That's going to be the y-intercept. For the x-intercept, what we do is we let y equal to 0. Okay, so in my simplified equation, I had 1 over x minus 4. I'm going to let y equal to 0. 0 is equal to 1 over x minus 4. If I cross multiply, I have 1 is equal to 0 times x minus 4 is 0. And this we know is not equivalent. So what does that mean? What that actually means is this graph is going to have no x-intercept, right? And if I go to my graph, it doesn't actually have an x-intercept because that's a horizontal asymptote at the line y is equal to 0. So this graph never does cut the x-axis, so we have no x-intercept. That concludes part 2, and then there will be a part 3 for this lesson.